Kia ora Year 12. This is just a quick video to do one of the questions on factor and remainder theorem. So if you're doing this and you're in my class this year, this is actually one of the textbook questions. It's question 20 in exercise 1B, but because it's an exam question, I've gone back to the exam paper. So it's one where we're given a polynomial and we're asked to find a couple of constants in there. So we've got this polynomial here, and we're told it's denoted by px, which is the usual notation. We're also told two useful facts, right? So we've got x minus 2 as a factor of the polynomial, and when p of x is divided by x minus 1, the remainder is 4. And that makes sense because we've got two unknown things here. We've got a and b, and we've got two facts, so we should be able to figure it out. And we're going to use the remainder theorem for this bit here, and we're going to use the factor theorem, which we haven't really done yet. It's basically the remainder theorem for this bit here. So let's just start by writing out what's p of x. Well, p of x is this cubic. So let's deal with the remainder is 4 part first. So by the remainder theorem, we know that p of 1 is equal to 4, right? So we've got a linear factor, which is x minus 1. So let's figure out the value we need by setting that equal to 0, right? So x is 1. When we substitute 1 in, the value of the polynomial is 4, and that's the remainder. So that gives us our first condition. So p of 1 is equal to 1 cubed 1 plus a plus b plus 6, and that equals 4. And that gives me an equation in a and b. So a plus b is equal to -3. So that's kind of fact 1. Now the next thing is that we're told one of the factors. So if something's a factor, it means there's no remainder, right? So the remainder is 0. So x minus 2 is a factor. So p of 2 must equal 0. So p of 2 is equal to 2 cubed, 8, plus 4a plus 2b plus 6, and that equals 0. So cleaning that up, we get 4a plus 2b is equal to -14. And we've got a plus b is equal to -3. Now, I would do that by elimination, but I know lots of you guys would probably do substitution on it, so I'm going to do it by substitution. So substituting in here, we get a equals -3 minus b. We take that, substitute back into here, we get 4 times a plus 2b is equal to -14. -12 minus 4b plus 2b is -14. Let's see, so we end up with 2, adding that to both sides, is equal to, this is -2b, so 2 equals 2b, and b is equal to 1, giving me, at last, a is equal to -3 minus 1, which is -4. Now, just to be a pain, I'm going to now do that by elimination, and we'll just have a look at what's better. So going back up here, all I'm going to do with that second one is multiply it through by 2. So I'm just going to erase all of this to give myself a bit of working space. So 4a plus 2b is -14. 2a plus 2b is -6. 2a, subtracting the second from the first, so 2a gives me -8, generating a equals -4. Hopefully that's enough to convince at least some of you that elimination is often a faster method, right? So a is -4, and from there I can go and get my b value, right? So b is 1. So that's the first 5 marks of the question done. Right, we've got to figure out a and b. The next thing we have to do is, when a and b have these values, find the other two linear factors of p of x. So there are two ways to do this, and one of them is what we did in class today, which is polynomial long division. But actually that's not my favourite way. So I want you all to know polynomial long division, but often matching up the coefficients is just as easy. And there's another method called synthetic division. So if you're watching this and you're not happy with how I'm doing them, that's fine. But this is kind of the polynomial long division way to work. Right, so we've got x cubed minus 4x squared plus x plus 6. So we could use this to practice the new method that we've got today. So x times what will give me x cubed? Well, we've got x squared here. X cubed minus 2x squared, bracket, bracket, minus. We're subtracting that. We're left with negative 4x squared plus 2x squared, so negative 2x squared. Bring this down, we've got plus x. Right, now we're matching on this thing here. We've got minus 2x squared, multiplying this by this, right? So here we've got plus 4x. And we're getting the difference between those two things. We're seeing what's left over. So we've got x minus 4x gives me negative 3x. Now this comes down, so negative 3x plus 6. I need to multiply x by what to get to negative 3x? Well, it's got to be take away 3. And that gives me here negative 3x plus 6. Now we know we've done that right because look, we've ended up with nothing left over. So where are we at? Well, we've got our polynomial and now we've got a linear and a quadratic term. So we can write, doing it that way, p of x is equal to x minus 2 times x squared minus 2x minus 3. Factorising, we get x minus 3 times x plus 1. Now let's just read the question back to see what we were asked to do, and then I'm going to show you another way to do it, which is worth looking at. So find the other two linear factors. So we just need to state what they are. So factors x minus 3 and x plus 1. Okay, so what's my kind of, how would I do it? Well, I probably wouldn't do polynomial long division. And what I would do instead is to write this out. So we've got x cubed minus 4x squared plus x plus 6. And we know that the first factor that we found was x minus 2. So in general, if I've got a cubic here and I've got a linear term here, I must have a quadratic in here. So I can write it out, if I want to be really uptight, as ax squared plus bx plus c. And we just have to work out those numbers. But we can do a whole lot of it here by just matching up the coefficients. So let's see what I mean by that. Well, I want to generate this x cubed. So that must have come from this x times something in here. So that must just be a simple x squared, right? That gives me x cubed. Now we'll look at this bit in the middle last. Here I've got plus 6. Now I've got minus 2 here, negative 2 here. So what does this have to be? Well, this has got to be take away 3. Right? So we can replace that with this. Right, now here comes the cool bit. If we look at minus 4x squared in here, I can do it by matching up what I've got. So I've already got this times this, which is minus 2x squared. And now I need to subtract another 2x in here to make it work. And we can quickly see by expanding that that's going to work on all of it. Right? So we've got x cubed minus 2x squared minus 3x. So how have I got that? Well, that's multiplying everything through by that, by the x. Right? And now I'm going to do the same thing with this bit here. So minus 2x squared plus 4x plus 6. Now just notice that I've lined that up in place value terms because that makes it harder to muck up. So that gives me x cubed minus 4x squared plus x plus 6, which is what we wanted. Right, and so now all I've got to do now is to factorise that. So I'm just going to magically erase that. And factorising this, we get what we got before. We get x minus 3 times x plus 1. So there you go. They're two very useful methods. I will show you another one, but not in this video. And often you don't need to use polynomial long division, but sometimes you do, especially when you're dividing by up here, when this is not a linear term, right? So if that were a quadratic. So it does come in useful. I really want you to be confident with both of them. Thanks for watching. That's all for now. Hopefully you can follow the work solutions that are on Google Classroom for the other harder questions in that exercise.